So we talked about sine and cosine graphs in 4.5. So in this lesson, we're going to talk about the other trig functions. So that would be your tangent and then your inverse functions. So tangent's an odd function, and remember that tangent is equal to your sine over your cosine. Therefore, that's what these three little dots right here in this triangle form. Therefore, tangent theta is defined for all values where cosine theta is equal to 0. All right? So it's undefined because cosine is on bottom, right? And therefore, you can't have a 0 in the denominator. That means that those are the spots where you will have an asymptote. Okay? So, for example, that would be positive pi over 2 and negative pi over 2. So if you take a look at your unit circle, your tangent values in this quadrant are the same as your tangent values in this quadrant, right? And these tangent values are the same as these tangent values. So when we talk about tangent, we're only going to go from 0 to pi. So remember, the period for sine and cosine was 0 all the way to 2 pi. But we are only going from 0 to pi for tangent. So instead of going all the way around, we're focused on these two quadrants, all right? And remember that when we are at pi over 2 and negative pi over 2, those are where we are undefined, all right? So I said 0 to pi, not 0 to pi. It's a distance of pi, so therefore we're going from pi over 2 to negative pi over 2. So we're focused on these two quadrants. I apologize. All right, now, this is a bunch of info. So for y equals tangent of x, your period is pi. That's how long it is from the beginning to the end, all right? And you're going to go between your asymptotes, all right? So your domain is everything except when your x value is pi over 2 and where I keep adding pi to that, because then I would be hitting the 3 pi over 2 and then keep going around top to bottom. All right, your vertical asymptotes are pi over 2 plus n pi, all right? And my range goes from negative infinity to positive infinity. So these are a little bit different, all right? So for my equations, the first thing I'm going to do is find my asymptotes. That means I'm going to take the part where I'm taking the tangent, so whatever I'm taking tangent of, I'm going to set that equal to negative pi over 2 and positive pi over 2. That's going to give me my asymptotes, all right? Then my graph will be between those asymptotes. The midpoint between my two asymptotes, that's my x-intercept, all right? So if I have an asymptote here and I have an asymptote here, then I know halfway that's where I'm going to cross the x-axis, all right? The period is the distance that's between my two consecutive vertical asymptotes, so from here to here, okay? And we do not have a defined amplitude. So let's get the ball rolling here. Oh, I don't think we talked about the graph of, let's talk about the graph of our regular, like our parent function. So draw yourself a little graph here. That way we have something to compare to. So on these, you're going to be graphing an asymptote, all right? So for the parent function, your left asymptote would be negative pi over 2, and your right asymptote would be pi over 2. And remember, asymptotes are lines that we approach, but we do not cross. So they are signified by a dotted line on your graph. So you're going to go right through your negative pi over 2 and right through your positive pi over 2. All right. And then I know that halfway in between these would be my x-intercept. Well, if this is pi over 2 this direction and pi over 2 this direction, then that would be my intercept. So I find that first. And then I'm going to plot 2 points, all right? One of them is going to be halfway in between my x-intercept and the left asymptote, and the other one will be halfway in between my x-intercept and the right asymptote. So if I were to go halfway between, I would really just be adding my x values together. So this is 0, right, plus a negative pi over 2. And then to find the halfway point, you just divide by 2, right, which gives me negative pi over 4 is what this is. And then the right side, I mean, this is the same distance this direction as it is this direction. So this one, the other halfway point would be pi over 4. Now, you're doing tangent, right? So you want to figure out what the tangent value is at negative pi over 4 and at positive pi over 4. So if you take a look at your unit circle, pi over 4 is right here, correct? Negative pi over 4 would be that distance to the left or to the right. So I've got square root of 2 over 2 divided by the square root of 2 over 2, because remember we are y divided by x, or sine divided by cosine. That gives me a value of 1. And if I go to negative pi over 4 on my unit circle, and I divide the y by the x, that gives me negative 1. So this is my parent function. So I would go to negative pi over 4 and down to negative 1. I would go to positive pi over 4 and up to positive 1. And it makes this like squiggly thing. So what you want to do is you want to start a little farther down. You don't want to touch this line, but you're going to come up and you're going to go through here, through the center, and then curve back towards this other asymptote and put some arrows on the end. So this is what the tangent graph looks like. Now remember, when we start changing things within the equation, then things start to change. They shift left, right. You stretch that up. You know, shrink it, whatever. Okay. All right. So the first thing that we are going to do is we're going to figure out what our period is. And remember, period represents the distance from the first asymptote to the second asymptote. Well, I already know that we start with a period of pi, but when we start changing things, then that changes. So we're going to take that pi and we're going to divide it by whatever we are multiplying by the x value here. So I like to move the x to the side, so this is really 1/2 times x, right? So I'm going to divide that by 1/2, and anytime we have a fraction inside of a fraction, we keep change flips. So I would actually multiply by the reciprocal of that 1/2, which would give me 2 pi. All right, for my asymptotes, I'm going to take what I'm taking the tangent of, which is the x over 2, and I'm going to set that equal to negative pi over 2. And then I'm also going to take it and set it to positive pi over 2, because those are my original asymptotes. And then I solve for x. So I'm just going to multiply by 2. So my left asymptote is going to be negative pi. Same thing over here. I will multiply by the 2. So my right asymptote is pi. Now remember, your period should be the distance from one of these to the other. So if you think about it, if I go from negative pi all the way to positive pi, that's a distance of 2 pi, right? It takes me a pi to get back to the center and then a pi to get over here, so that's 2 pi. So we know we're good there. So then we're going to locate our x-intercept. So your x-intercept is halfway between this asymptote and this asymptote. So you're going to take those and you're going to add them together, and you're going to divide by 2. which gives you 0. Now, when I get to 0, I like to go ahead and make my point over here. That's going to represent like the x value, all right? And if you didn't add or subtract a number on the outside of this tangent, then this will just be a 0, okay? Also, if you didn't multiply a number in the front, because that'll stretch or shrink, okay? Then we're going to do our left point. I'm going to abbreviate that as LP if you want to actually write out left point or make yourself a note. All right, your left point is in between your left asymptote and your intercept. So I'm going to take my left asymptote. My intercept was 0. So I'm going to add that to 0, and I'm going to divide by 2. Well, if I take negative pi and I add 0, I get negative pi, and then I divide that by 2. So negative pi over 2. Now, normally I would go down 1 on the left, right? I didn't multiply by anything that would need to stretch or shrink that, so that will stay a negative 1. My right point, which I will abbreviate as RP, that is halfway between the center and my right asymptote. So I'm going to take that and add that to the pi and divide by 2, which gives me pi over 2. And on the right side, we normally go up to 1. We didn't add or multiply by anything that would need us to, move that in any way, so we will stay at 1. These are kind of like the key points from sine and cosine, all right? So now that we have all that information, we are ready to put it on a graph. So draw yourself a graph. All right, so I know that I'm going to go pi over, that's my left asymptote, right? And then pi in this direction. And you want to try to make sure that they are equally spaced out. And put your asymptotes there. All right, then I know that my x-intercept is 0, 0. So I'm going to put that point right there. And then I know that my left point is halfway, right, between the 0 and the pi, so halfway. That represents the negative pi over 2. I actually never label these halfway points between the intercept and the asymptotes, just because it's hard to draw my graph in. So this would represent the negative pi over 2, and then I'm going to drop down to negative 1 and put my point. My right side point, I would go to positive pi over 2 and go up to 1. And then once I've got it all on there, I'm ready to draw it in. So I'm going to get close to my intercept. I'm going to curve through and then start getting close again. Remember, we don't want to touch or cross our intercept. All right, so on this one, we're not only multiplying that inside value by a 2, but we're multiplying this by negative 3. And I want you to think about this. Anytime we multiply by a negative, something ends up happening, right? We end up flipping. So this one is actually going to be backwards, all right? But let's start by finding all the info we need. So our period, remember we want to find the distance from one asymptote to the next. So my period starts with pi. And then I'm going to divide that by whatever I'm multiplying the x by. So I'm going to divide that by 2. So from one asymptote to the next asymptote is only a distance of pi over 2. So this one is kind of smushed together a little. Then I'm going to locate my asymptotes. So I'm going to take whatever I'm taking the tangent of, which is the 2x, And I'm going to set that equal to negative pi over 2. And I'm going to set that equal to positive pi over 2. Then I just solve for x, so I divide by 2. So negative pi over 2 divided by 2 would be negative pi over 4. And then same thing over here, divide by the 2, and you get positive pi over 4. And I will point this out, until you start adding and subtracting numbers, this is going to stay, like this one will be a negative and this one will be a positive, and you'll be halfway in the middle. When you start adding and subtracting numbers and moving it left and right, then that shifts. All right, so now our x-intercept, I know that that is halfway in between my two asymptotes. So I take them and I add them together. And I divide by 2. And here's the thing, you can actually plug this whole thing in your calculator. I mean, I would hope that you would realize that halfway in between a negative and a positive that are the same, you would get 0, right? So I get 0. And normally I'm sitting on the x-axis. Notice I'm not adding or subtracting any numbers. So this is going to stay at 0. Then I'm going to find my left point. And remember, your left point is halfway between the left asymptote and the 0, right? Your x-intercept. So I'm going to take the left asymptote and I'm going to add it to my x-intercept and divide by 2. When you do that, that's going to give you negative pi over 8. Now, I did multiply by a number here, right? So normally on the left side, I would be sitting at negative 1. But I'm going to multiply it by that negative 3, which is going to give me positive 3. So it's kind of like the key points, right? You do the same thing with your points here. All right, my right point is in between the center and my right asymptote. So I take the center, I add that to the right asymptote, and I divide it by 2, which gives me a positive pi over 8. Now on the right side, you're normally sitting up at 1, right? But we have to multiply that by the negative 3. So now I'm going to be at negative 3. And now we're ready to draw our graph. All right, so pi over 2 to the left and to the right. Those are my asymptotes. All right, I know halfway in between, I've got my x-intercept is at 0, right? We have not shifted that at all. And then I know halfway between these two are my points. So I've got negative pi over 8. I'm going to go all the way up to 3. See how we have flipped? Normally we're down here, but now we're up here. And then positive pi over 8 and down to negative 3. This one it won't be quite as curvy just because it's stretched a little. All right, so now we're changing a little bit more on this one. We are multiplying by a number in the front, so that means we're going to shrink or stretch, right? This is in between 0 and 1, so we're actually going to be shrinking. And now I'm adding a number on the inside. So remember when you add a number on the inside, that moves you left or right. If you add it, that moves you to the left. If you subtract that number, it moves you to the right. Okay? Uh, and you can also move up and down, but that's only if you add or subtract on the outside, right? Out in the front or back here, not inside the parentheses. All right, so first thing we're going to do is figure out what our period is, so the distance from one asymptote to the next. So I take what my period normally is, which is pi, and I'm going to divide that by what I'm multiplying by the x. So x is getting multiplied by the pi over 4. So I'm going to divide by the pi over 4. So if I work that out, I get 4, because my pi's are going to cancel. And again, you can just plug that in your calculator if you want to. Just make sure when you do that, that you put the fraction box in the bottom of a big fraction instead. Like, you have to pay attention to which bar is longer, right? All right, so I just get 4 because my pi's ended up canceling out. So that leads us to, if we have a pi left for our asymptotes, then we've done something wrong. So for your asymptotes, if you want to abbreviate that, you can. I'm going to take what I'm taking the tangent of, which is this big long mess. So pi over 4 times x plus pi over 4. I'm going to set that equal to negative pi over 2. And then I'm going to take the pi over 4 times x plus pi over 4. And I'm going to set that equal to pi over 2. Now, when we get done, from the left asymptote to the right asymptote, it should only be a distance of 4. All right, so we want to make sure we come up with that. So I'm going to solve for x. So first I'm going to subtract the pi over 4. So I have pi over 4 times x is equal to, all right, so if I take negative pi over 2 and I subtract pi over 4, that would give me negative 3 pi over 4. And you can plug that directly into your calculator as well. And then you can divide by pi over 4, or you can multiply by the reciprocal, which is what I'm going to do. I'm going to multiply by 4 over pi. So my pi's cancel and my 4's cancel, leaving me with negative 3, which makes sense, right? Because we don't have a pi left up here on our period. Okay? And then we go through the same process over here. So I'm going to subtract the pi over 4. That gives me pi over 4x is equal to pi over 4. By the way, if you're just thinking and making connections, if it's a distance of 4, this should end up at a 1, correct? Because negative 3 to 0 is 3, right? And then you need to go one more. So if it doesn't end up that way, then did something wrong. So I'm going to multiply by the reciprocal. So x is equal to pi divided by pi is 1. 4 divided by 4 is 1. So we just end up with 1. All right. So that is a distance of 4, right? Every step of the way, you should be able to kind of check yourself, because if this ended up being like, let's say 2, that's a distance of 5. So that you know you're either wrong here or you're wrong here, right? All right. So now we need to do our points on the left and the right. So our left point, let's do our intercept first. I skipped it. So our x-intercept is halfway between the left asymptote and the right asymptote. So I'm going to take the two numbers and I'm going to add them together and divide by 2. So negative 3 plus 1 is negative 2, divided by 2 is negative 1, which makes sense, right? If you think about a number line, this is 0, this is negative 3, and this is 1. They are 1, 2, 3, 4 apart, right? If I go 2 in, that's halfway. Yes? All right. So I know that that's the x value of my intercept. Now, I didn't move up or down at all, right? So I will stay at 0. If I don't add anything on the outside, I don't need to worry about moving that up or down. All right, so let's talk about our left point. Our left point is halfway between the left and asymptote and your intercept. So I'm going to take the negative 3, and I'm going to add that to my x-intercept, which is the negative 1, and I'll divide that by 2. So negative 3 plus negative 1 is negative 4, divided by 2 is negative 2. Now, normally on the left side, we're at negative 1, correct? Well, I've done a few things, right? I have multiplied by this 0.1. So I'm going to take that and multiply it by 0.1. Negative 1 times 0.1 gives me a negative 0.1. All right, now my right point, that's halfway in between my x-intercept and the right asymptote. So my x-intercept is negative 1. I'm going to add that to my right asymptote and divide by 2. That gives me 0. Now normally on the right side we are sitting at 1, but we have to multiply that times the 0.1, so we get 0.1. Now we have all of our info and we are ready to graph. So you do need a little more space because you did shift to the left. All right, so my asymptotes are at negative 3 and 1. So 1, 2, 3, and positive 1. All right, my x-intercept is at negative 1, 0. My left point is at negative 2, negative 0.1. So if this is negative 1, it's a tenth of the way down, right? So super close right here. We squished it. All right, and then I know that my other point, my right point, let's say this is 1, would be 0 and up 0.1. So this is a really short, squatty kind of graph. All right, so on number 4, we've multiplied by this negative 3 out front. That means that we are going to flip, and it's going to get taller, right, because it's bigger than 1. And we also are going to have a period change here, but we are not going to shift left or right because we didn't add or subtract a number inside here, right? So this should stay right at the center. So let's talk about periods. So our period is normally pi, but we're changing that. I'm going to divide that by whatever is being multiplied by my x, so which that would be pi. So pi divided by pi is 1. So from one asymptote to the next asymptote is a distance of 1. And if we're thinking about how our equation changed, I told you that we didn't add or subtract anything, which means we didn't shift left or right, which means your center should be at 0. So if it's a distance of 1, where do you think your left asymptote is going to be? Nope, think about it. If we're normally at the center, it's a distance of 1, though, from the left to the right. So that means you would have to go, if this is the center, this side would have to be negative 1/2, and this side would have to be 1/2, correct? Because it's a half this way and a half that way, which makes a whole. Okay? And I like for you to think about things along the way, because if you're thinking about how your equation changes, then when you make a mistake, you can kind of catch it. All right? So our period is a distance from 1. I didn't go to the left or to the right because I didn't add or subtract a number right here. Okay? All right, so now let's talk about our asymptotes. We already know what they should be, but we're going to do the work for it. So I'm going to take what I'm taking the tangent of, which is the pi x, and I'm going to set that equal to negative pi over 2. And then I also take that and set that equal to positive pi over 2. And then I just solve for x. So I'm going to divide by pi. So x is equal to negative 1/2, which is what we were already thinking. Same thing over here, divide by pi. And x is equal to positive 1/2. So we were correct in our thinking, and that is a distance of 1. So for your x-intercept, even though we already know that halfway between a negative 1/2 and a positive 1/2 is 0, right? We're going to do the work. That way we have it to look at. So I take the left asymptote, I add that to the right asymptote, and I divide by 2, which gives me 0. All right, so we're normally at 0. We will stay at 0 because we didn't add or subtract a number on the outside. The only time this number would change is if you added or subtracted a number outside somewhere, like if this said plus 4. I would need to add 4 to that. But I don't think that we're going to be doing any moving up and down. We're going to just stay right there on the x-axis. So the left point, I will take my left asymptote and add that to 0, the x value here, and I'll divide by 2, which gives me a negative 1/4. All right, so normally on the left-hand side, we're at negative 1. We need to multiply by this negative 3 out in front, which we already know multiplying by a negative out front is going to flip it. So this is going to change to a positive 3. For my right point, I'll take that x of my x-intercept, which is 0, and I'm going to add that to the right asymptote and divide by 2, which gives me a positive 1/4. Now, normally on the right side, I would be sitting at 1, but I'm going to have to multiply that times the negative 3, so I'll actually be at negative 3. Now I have all the info, and I'm ready to graph. All right, so I'm going from negative 1/2 to positive 1/2. Zero, 0 is my x-intercept, and then halfway between here, that would be the 1/4 and the negative 1/4. So I'll be going down 3 and up 3. So negative 1/4 up to positive 3, and positive 1/4 down to negative 3. So this did stretch it, right? Made it a little bit more elongated. Okay, for the cosecant and the secant, you're pretty much going to do the same thing that you did for sine and cosine, and you graph them and everything. But once you get all your key points on the graph, then you do something different with them. So cosecant, that's the inverse of sine. So we're going to actually do all of the steps that we did for sine. All right, remember, this is going to stretch or shrink. Adding or subtracting inside here moves it left or right, and if you add or subtract something on the outside, that moves it up or down. Okay, so let's start with our amplitude. Remember, that's the distance from like your minimum to your maximum. So that's just the absolute value of the number on the outside. So that would be 2. So I know that from my minimum to my maximum is going to be a distance of 2. All right, so to the middle part would be 1. All right, then we're going to talk about our period. Now remember, your period for sine and cosine is 2 pi. But you're going to divide that by whatever you're multiplying by x, which in this case is just 1. So does that really change anything? No. But remember, we're going to break this up into 4 equal parts. So every single part, if I divide that into 4 equal parts, will be pi over 2 in length. All right, so I know that between one point to the next, the x values are pi over 2 apart. Okay. Then I'm going to do my end points, so where I start on the left and where I end on the right. That should be a distance of 2 pi apart. These are kind of like your asymptotes in a way. Okay, so we've got what we're taking the sine of, and we're going to set it equal to our normal endpoints, which are 0 and 2 pi. Now remember, when we get done, this is going to shift this to the left because I added. Okay, it's going to shift to the left pi over 4, but it should still be a distance of 2 pi apart. So I'm going to subtract pi over 4. So my left endpoint, where I'm going to start, will be at negative pi over 4, which makes sense, right, if I shifted pi over 4 to the left. And then I do the same thing over here. I subtract this pi over 4. So I get 7 pi over 4. So this is where my first point will start on the x-axis. This is where my ending point will be. And remember that I should have 5 key points. And this should be the first one. This one should end at the last one. So I've got negative pi over 4. And then we'll figure out the ones in between. 3, 4, 5. So remember, this last one should end at 7 pi over 4. If it doesn't, then you've got some kind of issue in here somewhere. So every single time we're going to be adding pi over 2. So if I take negative pi over 4 and add pi over 2, that gives me pi over 4. And then if I add pi over 2, that gives me 3 pi over 4. And if I add pi over 2, that gives me 5 pi over 4. And then if I add another pi over 2, that gives me 7 pi over 4. Now remember, sine normally starts at 0, goes up to 1, back down to 0, then to negative 1, and then down to 0. But what changes that is when you multiply by a number on the front, or you add or subtract outside, not inside here. So I need to multiply by 2. So 0 times 2 is 0. 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2, and 0 times 2 is 0. So we will graph this just like we did when we did sine and cosine. Now, remember, you want to find a good value to count by. If you look at these are all going by pi over 4s, right? So when you do your counting, count by pi over 4s. So I've got negative 1 pi over 4, 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7 pi over 4. 3 pi over 4, 5 pi over 4, 6, 7 pi over 4. Remember, I always find a common denominator, and then that's what I count by. These already have a common denominator of 4. All right, then we're going to plot these points just like normal. So negative pi over 4 is 0. I'm going to go all the way up to 2 and all the way down to negative 2. So then positive pi over 4, 2. 3 pi over 4, 0. 5 pi over 4, negative 2. And 7 pi over 4, 0. Now this is where you do something different on your graph. So this was exactly like what we did a while ago, right? Now, instead of drawing the curve, because that would be sine, right? You want to do the inverse. So what you're going to do is you're going to put an asymptote everywhere that you have an x-intercept. So that would be here, here, and here. All right? So these are going to be the guidelines, and then you're going to draw a couple of what I would call like parabola-looking things. So if you have a maximum up here, then that means that this is going to open up. And if you're down here with this minimum here, we're going to open this direction. So I always start here, and I'm going to kind of swoop out towards that. And then same thing on this side, swoop out and approach, but don't touch or cross these asymptotes. And then the one on the bottom, we're going to do the same thing, but we're going to go down and down. And then you have graphed the cosecant. All right, so for secant, that's the inverse of cosine. So we're going to do cosine 2x. Now, this will not shift left or right at all because we didn't add or subtract inside. It's not going to move up or down because we didn't add or subtract on the outside. It's not going to shrink or stretch because we didn't multiply by a number up here in the front, right? The only thing that's going to happen is it's going to change our period because we multiplied something times the x. All right, so I'm first going to think about my period. So my period is normally 2 pi, but I'm going to divide that by whatever I'm multiplying by x. So I know from beginning to end is a distance of pi, and I'm separating that into 4 equal sections. So I'll take that and divide it by 4. So every section, every point will be pi over 4 apart. All right, so for your end points, you're going to take what you're taking the cosine of, which is 2x, and you're going to set it equal to 0, and you're also going to set it equal to 2 pi. So I divide by 2. That didn't change the left side at all, right? And I'm going to divide by 2, which gives me pi. So from 0 to pi, that's a distance of pi, right? So I know this is where I'm starting, and this is where I should end. So for my key points, I know the first one should be 0, comma something. And the last one should be pi something. If it's not, then I know I've done something wrong. So every time I'm going to add pi over 4, so 0 plus pi over 4 is pi over 4, plus a pi over 4 is pi over 2, plus pi over 4 is 3 pi over 4, plus pi over 4 is pi. And remember, I like to write these with a common denominator. So the common denominator would be 4, correct? So if this is 1 pi over 4, this is 2 pi over 4, 3 pi over 4, and then this is 4 pi over 4. So I'm counting by pi over 4s, right, when I graph this. Now, with cosine, I normally start at 1, go to 0, drop to -1, back up to 0, back up to 1. Is that going to change at all? I didn't multiply by anything up here, right? So it's not shrinking or stretching, and I didn't add a number on the outside. So this isn't going to change. They will stay the same. That only changes if you multiply by a number out front or you add or subtract outside, which we're not adding or subtracting outside, just so you guys know. All right, so now I'm ready to graph. I really don't need anything on the left side, so I'll keep it all on the right. And I'm going to count by pi over 4s. So 1 pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4 would be your pi, right? I'm just going to label a couple of these. And then I'm going to go up to 1 and down to -1. So plot those points. 0, 1, pi over 4, 0, 2 pi over 4, -1, 3 pi over 4, 0, and pi 1. Now, instead of drawing your curve, right, like we normally would, we're going to put asymptotes where your x-intercepts are at. So right here and right here, which my asymptotes are kind of wonky looking. So remember, the high and low points that are left are where you're going to be drawing. So this bottom one is going to go down. And this one, you only need to draw the point, draw the side that's right here next to the thing. So since this is a maximum, it's going to go up towards this and up towards this. So these are kind of funny looking, but they are what they are. So you don't need to draw like this side because you don't have a guideline over here, right? So we'll just draw the side that goes with this. So the ones that are on top go up. The ones that are on bottom go down.